Hi, I'm Dan Gordon, a technical evangelist here at Traceable. I'm excited to show you how Traceable helps you protect your next generation application architectures and APIs by combining security observability with artificial intelligence and machine learning. The adoption of cloud-native application architectures and DevOps practices have increased the speed of software delivery, but also increased the complexity and attack surfaces of our modern-day apps. It's become harder to protect your apps and APIs, but also harder to keep track of how they are changing. Web application firewalls, or WAFs, help protect against OWASP top 10 web application threats, such as SQL injection. So can Traceable. Here's Traceable identifying an SQL attack as a high threat. But while necessary to still guard against those threats, it's no longer sufficient. New application architectures have added an entirely new threat landscape out there at the API level. There is now an OWASP API top 10 threat list, and the number one threat on that list is called Broken Object Level Authorization, or BOLA, formerly known as IDOR. BOLA can manifest in millions of ways because the attack is based on your business logic. Let's take a look at what that looks like and how Traceable can identify and protect against it. What happens when someone flips a bit and it gives them access they shouldn't have? BOLA is by far one of the hardest to solve and most prevalent of the OWASP API top 10. Let's see how that plays out and how Traceable is uniquely positioned to handle it. We're going to pop into a lightweight Shopify-like app, and I'm already logged in as the bad actor. Coming in to this app, I'm going to poke around and see what's what, get a feel for the app, and try and find a way in. I may look at something inexpensive like this air plant and add it to my cart. Maybe even place an order so that I can do some reconnaissance. Now with that, I can go check my orders. And then taking a look at that order, I can see that there's personally identifiable information being shown. My user ID/email, my shipping address. But the other thing that I notice is that my order ID is in the URL, which makes me think, let's poke around and see if I can look at some other order ID. And sure enough, I can. This is Broken Object Level Authorization. Because I had authorization to look at my object, the system is letting me look at all objects of similar type. So here I'm able to see the email address of jgeyer@AOL plus a shipping address. So if I poke around more, it looks like I've got pretty good access to collect a list of personal information that I can then turn around or sell, or maybe use for identity theft later. This is a common business logic attack. People try to prevent this by having the right authentication checks in place, prevent it by proper random enumeration of things like order confirmation IDs. But at the same time, it still happens. Software is not bug-free. Developers are under pressure to move fast and deliver quickly. Humans are fallible. This example happened with Shopify. We've seen similar attacks happen to T-Mobile, Facebook, Uber, Twitter. These are all companies that have mature security organizations and developers. But at the end of the day, you need some form of compensating control for user error. And that's where Traceable fits in, because we are tracking and tracing user transactions. We build a state machine for each and every API endpoint. Looking at the threats list, based on the reconnaissance I've done so far, I have shown up as a recent threat actor. If I go and look at the details, everything I've done since I registered with this application is shown. So instead of having to look through 15,000 or more security events across all of the different services, Traceable has consolidated that for me, and I can focus in on the ones that are relevant to me. And it shows you all the alerts that my user has triggered which could also include things like the SQL injection from the OWASP regular top 10. But Traceable also specializes in identifying abuse of business logic, which happens to be the situation over here with this authorization bypass. And as you can see, we called out the fact that this particular user tried to access someone else's orders. We're able to do that because we build a state machine for each endpoint. So we know who the users are. We know what are the APIs. We know what are the objects in play behind those APIs. And we have learned the expected transaction patterns based on everything that we've seen before. I want to emphasize that this is automatically learned for every API endpoint that your system has. And in this situation, we know that the order ID is a unique identifier that is generated by the backend first. It has to be supplied by the backend to the UI, which is being observed by the user before that user goes in and accesses that order ID. And in this particular case, the behavior is in violation to the state machine that we've learned. That's why we're calling it out. It should have appeared as part of the get past orders call, but it didn't. And so that's why the AI triggered on it. It's marked as something that is high priority because the backend complied. It came back with a status code of 200. So this is just one example. There are millions of potential manifestations of these business logic attacks because they are based on your specific business logic. And this makes them near impossible to detect and block without security observability and AI. So how does Traceable help you keep an overall view of the security posture of your environment? We're looking at the Traceable dashboard. It is showing you that overall posture with this radar graph, which looks at 4 vectors: the security events, the calls per minute, the assets at risk, and the new threats that are showing up. I can look at those over time, past hour, past day, past week, and compare them to see what changes are being made. Am I getting better or worse? On the right-hand side, you can find the most recent active threat actors that we have observed in this environment, including user attribution. Traceable also automatically discovers all the assets in your environment. These graphs show a high-level summary of what has been discovered. This deep discovery comes from Traceable without you having to do anything. The overview differentiates between the assets that are exposed to the outside world, called the edge APIs, and the internal services, where you're likely to see a completely different set of attacks. The dashboard also summarizes the top alert types that have been observed in this environment. We can see that BOLA is pretty high. We're also getting some anomalies, SQL injection, restricted file access attempts. In general, the dashboard gives you a 10,000-foot overview of the security posture of your environment, including things like the number of calls, errors, the median latencies, and the security posture of those top services. But how does it get all that information? As soon as you deploy Traceable, it will, within a few hours on average, discover all your APIs, all the way from the edge through the internal microservices to the backends, like the databases that they might be speaking to. It also discovers the interactions that they might be having with each other. So this is literally a live application dependency map with additional information like the latency and error count and the call rate, which you can see in the black box. And if you're interested in a specific microservice, you can dig down deeper. And you can see the same performance metrics, but focused on this particular microservice. We also include a radar of the health of this microservice that looks at multiple different points of information. And looking down here, we can also see insights about the interactions that the service is having, both inbound and outbound, and summary information about the service's endpoints, including information about the security posture. But what's really exciting is that we can get a deeper view into all the endpoints in this service, not just the top ones. Here, you're seeing a live catalog of all the API endpoints that make up this particular microservice. This information is all automatically collected by Traceable based on the interactions and data traffic that we have seen. And because Traceable brings intelligence to its mapping, we can reverse engineer that traffic to give you the catalog of all your API endpoints, along with the access methods used for each of them. This view also gives us some details used to determine the endpoint's risk profile, like if it is an unauthenticated endpoint, or if it has private information, and if that API definition has been observed as changed over the previous period. Taking it one step further, you can go even deeper and you can get more of the discovered and collected data about this particular endpoint, such as the overview, the events that have happened to it, the traces that it's been a part of, and the definition. So here I can see the parameters that are being exchanged, whether those parameters have any sensitive information in the PII column. Now, notice there's also an overall risk score. We saw that in the other list. And it's a combination of several factors of likelihood of the endpoint getting compromised based on information such as whether it's authenticated, whether it's internal versus an edge API. And that score is also comprised of the impact potential, whether that endpoint is exposing any PII, for example. So that's a quick overview of how Traceable can help you secure your next generation application architectures and APIs by combining security observability with artificial intelligence and machine learning to identify and protect against OWASP top 10 and OWASP API top 10 threats, and to give you service and API mapping and change visibility of your entire application environment. Thank you for your time, and to learn more, find us online at traceable.ai.